afternoon to you all, and welcome once again to today's session. So far, we've been looking at the human computer so we've been looking at how computers tend to. As I was saying, we're looking at how we can make our systems to be user friendly for any caliber of users to uh, use the system. But in here, today I'm going to look at how the human brain works. How the human brain works, trying to process information so that when users get to your UI designs, your application, they will understand things faster so that they will be able to enjoy. So for you to be able to design something that the human can enjoy, you must first understand how the human tend to process information. So in here, one of the things we're going to look at is the attention switching. Most people even think the computer does multiple tasks at the same time. Meanwhile, that ideology is not true. The CPU, let me pick just one CPU. Now, the CPU actually does not process multiple tasks at the same time. It's just like the human brain. We don't do two things at the same time. But what actually happens is that there is something we call attention switching. We switch from one task to the other. So just like the brain, the CPU cannot process two instructions at the same time, but rather, because of how fast it is, it rather deals with one task, finishes, then goes to the next task. So because it is that fast, we always tend to think that the computer is doing multiple tasks at the same time. So the human brain tends to process information from the first step of what we call the attention switching. So attention switching is the switching from a current state to a new one focus. So a person's decision to focus attention on a particular location in space, either in response or a cue to acquire new information in a natural situation. So when you are doing something and you stop to do another thing, that is where your mind is being switched from the previous state to the current state. Now, it is known that we have what we call the switch of virtual attention is not instantaneous. So for you to switch from one web to another, it is not instantaneous. But what happens is that there is an opening and the closing of what we call the attention gate. There is the opening and the closing of the attention gate. So the moment your brain is being captured to a new action, then you open your attention gate. Then whatever information your eyes, your ears, your skin is trying to pull into your memory, after it is done putting in whatever is in the memory, it closes the attention gate. Then further information is being processed within your brain before it gets or you are able to accomplish that particular task. So human beings tend to switch from one information to the other. When any human being wants to process anything, it must first open the attention gate, work with it. So the information comes, it closes. So now, if you remember how the CPU works, when data is being fetched from the memory, it goes on to the register within the CPU. So a few information is being given to the CPU. It will work on it, then it will now go back again to the RAM. So that is how the human brain also works. So let's move on now. Temporal characteristics of the switch of attention have been treated quantitatively. A key cue to switch attention produces after a short delay, the opening of the gates at the cue location. Information at the new attend location is gated into memory. The memorial representation is the basis for the conscious awareness of information at the cued location. So this is still explaining how information is being picked. Now we know that, or from our SHS level, we know that we have about 5 senses, of which we have our eyes for vision, we have the skin to feel something, we have the nose to smell, we have which other one am I skipped for the 5 senses that we have? Taste, yeah, we have taste too, yeah, but taste doesn't work here because we can't taste our software, okay, yeah, that one is also a part, but the 5 senses that we have, the 5 senses that we have, these are ways we can attract information into our memory. So when your users see anything from their screen, then they start processing the information in their mind. So their attention is being switched from one point to the other. Right. So the information process approach to cognition, which is thinking. So there are some principles that the brain does when it is trying to process information, and there are 4 of them. The first principle is that the first is the assumption of a limited processing capacity of the mental system. This means that the amount of information that can be processed by the system is constrained in some very important ways. Now, we believe that there are some people who are more intelligent than others. So we've all been students before. You realize that somebody will be like, hey, my intelligence is different from this guy's intelligence, and we do that after exams. You see people in first class, you see people in second class, and in third class, whatsoever. It is because the brain is different from each other, from one human being to the other. Every brain has a limit that it can consume information. That is why when you are in nursery, the things you are supposed to learn is different from the things you are supposed to study when you are in a JHS, SHS, and university. So there is a limitation to our processing capacity as human beings. So if you're able to understand how this limitation works, when you are creating a system, you will be able to know that, okay, this that I'm designing, if I'm designing to accommodate children, so I'm designing a system for the middle class to also use the system. I'm designing a system for the senior citizens to also use. You are able to factor all other possible attributes to be inculcated into the system. So you should know that, okay, as I'm developing the system for a particular class of people, I want to get the mass, or I want to get everyone to use the system. So we're looking at the various brains in the system. So how will a child understand this section of the system, the interface? So and on, when you're able to answer these questions, then you realize that your system can be used by most people within especially the country or the world. Yeah. So you should also know that there are limitations to our human brain processing speed or the processing capacity. Now, one of the other principles is that there is a control mechanism required to oversee the encoding, transformation, processing, storage, retrieval, and utilization of information. Yeah. So another principle that you should bear in mind that the brain can do. Like I said, every brain has a level of information that it can process based on the person's intelligence. Now you could remember that there are some people who have problems. They can remember things quickly, and we have some people who will be able to remember things, but they are slow in remembrance. Now, so the second principle is saying that there is a control mechanism that is required to oversee the encoding, transformation, processing, storage, retrieval, and utilization of information. That is, not all of the processing capacity of the system is available. An executive function that oversees this process will use up some of these capability. Alright, so to further explain this, let's use an example to what I'm trying to say here. Now, when one is learning a new task or is confronted with a new environment, the executive function requires more processing power than one when is doing a routine task or is in a familiar environment. So what we are trying to say is that with the processing of information, you are bringing out a system. Sometimes the systems that you are bringing, nobody knows the system. You are the only one who knows how the system runs. But the system is going to be used by others. Now, with you, you realize that if you are even learning how to drive, when you begin how to drive, you realize that you need all your senses because it is a new thing that you guys are doing. It's a new thing that you are learning. So when you are learning something which is new, you tend to use more intelligence. You tend to make sure that all your focus, all your senses are high, and it is quite difficult to do that. So when you are in a new environment, you realize that learning there is not as easy as compared to something that you've been doing every time, each time, almost all day long. So when you are performing those tasks, your executive function does not require much energy. It's something you already know. So when you are retrieving information, it is quite easier as compared to when you are dealing with something which is not new. So it is always advisable that when you are developing any system, you bring out key elements that people are already familiar with. Because they are already familiar with, using the system does not become a problem. So bear in mind that when human beings are used to something, it is quite easier for them to enjoy than when they are now coming to learn the thing entirely. Yeah, so that is one way the brain works. So developing systems, you should ensure that you bring in items. Yes.
Please, there's some background noise. We can't clearly hear what you're saying.
Please give me a minute. Hold on.
Explain it.
No.
So imagine this.
You fill the form.
You're writing the code on the paper and you forget one line. Oh, your friend reminds you about the one line. It's not more practical.
You fill the form.
No, the rule in the examination center is you don't talk to your partners. You don't talk to anyone. That is the rule. But what you are doing is stealing. You understand? But
So
then
you said
when you did the stealing, you are not caught. Okay. I am trying to give you a comparison analysis here or comparative
yes, sir.
analysis that sometimes so it's okay. Let's come out of the examination center.
Oh, no. So what of
Maybe you
sign
are
language?
they are all there because they are
But
they are
you said
going to
if
help
we
you.
talk, but sign language is part. Like, you see, if I do
Yes,
my
it
friend a
is.
sign,
It is.
it's not all.
See, it is
Come on,
one
it
form
is
of
more. It is more
communication.
practice. What's
It
that?
is not.
It is more
Oh,
practice.
Say
Let me
please,
let me
sometimes
let,
you
let
just
me
need
give you
someone to remind you.
or
Yeah,
even just a word,
Yes.
and
just
you
a
can
word.
you can
A,
be able
a
to
word
explain
can
the
save
rest.
your life.
You don't need anyone to help you.
Hey, said, right now
It's a
that you
little
are telling us
clarification.
about the thing here, I want somebody to help
No,
me.
no, no, no. No, no, no,
Sir,
no.
please can you clarify something for me?
Before that, let me answer this. In examination center, you don't let anyone help you out. That is examination. You just concentrate on you and yourself and the paper and the questions that you are dealing with. That is all. But when you are trying to tell someone, but in the advent where you are asking someone anything, then that means you are violating the rules of the moral practice. So we don't do that. So just see this example as maybe you are talking to someone and you realize that when a person gives you a hint of the information, then you realize whatever happened in that particular moment. So somebody giving a hint is what I'm trying to bring your attention to, and not that you go to that. You don't go and say somewhere that say Kingsley says in examination we should be talking to people so that they can give us hints to be able to get our work done. I'm not saying that it is a more practice. Yes, ask your question. Ask your question.
Oh, sir, don't worry, you have finished
So
answering it.
all right, so good. Yeah, so there are several examples of elaboration that are commonly used in teaching and learning process. There are several examples of elaboration that are commonly used in the teaching and learning process. So in this, with a long-term memory, it's very good to ensure that information is being moved from the short-term memory into the long-term memory. And you can remember that when you see images, images are quite memorable. Okay, yes, images are quite memorable. So it's very a good practice to always use images to represent your words. So when you are building a system and you realize that the information you want to put across the board, you can use an image to represent it. Go for it. Okay, just go for it. That one, it helps. The images are easily learned as compared to what words. They also have what you call the peg word or what you call the rhyme. When information is in a rhyming, structure, it's easily, me. I normally don't listen to what we call a secular song, but somebody like Sarkodie, when Sarkodie is rapping, you will see the rhymings, and with just a single line or two, I can rap those lines. It is because of the rhyming, it makes things what easier. So when you are putting an information, um, let's say a warning, be it a critical information, try and put the information in a way that it will rhyme. Here it makes things what easily captured and remember, always easily retrieve from memory if one person wants to remember whatever information that you have put across the application. Yeah, so that will be the end of this particular session. Please, if you do have any questions that you really want to ask for us to elaborate. If not, probably we can call it a day, then meet next week. I'll be actually giving you an assignment to work on, and I think I'll bring a test. I'll send your class reps some tests. I mean, there are still assignments, so you see how I set my questions. Okay, yeah, because midterm is coming very soon. All right, any question? Hey, I've actually been disconnected.